Welcome again, and this is lecture is in continuation with the previous lecture. And now we shall discuss the current flowing mechanism inside transistor. So, how the current conduction takes place inside the transistor. So, let me draw the transistor now. This is the cross section. And I'm taking the NPN transistor. And what we need to understand, uh, in normal operation of the transistor, and normally we use transistor as an amplifier. So here we have two junctions. Here we have two junctions. This is the junction 1 and this is the junction 2. Here you can see, because these are the two different materials, two different kind of semiconductor. This is the N-type semiconductor, this is the P-type, this is again N-type. So here you can see there are two PN junction, and we all are quite familiar with the semiconductor physics behind the PN junction. So now we will discuss some of the basics from the PN junction, because we will use that basics. So I will discuss them again, and I have already discussed in the unit 1, and now we will discuss them again. But first let me give all the nomenclature here. So this junction J1 is called the emitter base junction. Emitter base junction. This junction J1 is called the emitter base junction, and or popularly it is also called the emitter junction. This junction J2 is called the collector base junction. So this is the nomenclature. This part is called the emitter, this is base, this is collector, and this is emitter, this is base, this is collector, and the terminals which are coming from these parts are also called that. This is emitter terminal, base terminal, and collector terminal. So this is the collector base junction. It is also called the collector junction popularly. So, and now what we need to understand, that in the normal operation of the transistor, we provide a forward biasing to this junction J1. Here you can definitely understand that there are four probabilities. Let me write down those all four probabilities. That now we have two junctions. This is junction J1, this is junction J2. Okay, and what we can do, uh, we can put, so now we know that the basic theory of the PN junction. Either we can, because a junction at the equilibrium we have studied, so there is no use of a diode inside, or if there is a diode which is on the table, so there is no use. If we are providing some kind of biasing, and we can provide the biasing in two ways, forward biasing or reverse biasing. So for a PN junction diode, we have only one diode, so either we can provide it here only one PN junction. So either we can provide a forward biasing or a reverse biasing. But here we have two junctions, so there are four combinations possible definitely. So this junction could be a forward bias, and this junction is could be a forward bias, or this junction could be a reverse bias, and this junction again could be a reverse bias. This junction could be forward bias, and this junction could be reverse bias. And the fourth combination we don't use. Okay, so basically as an when we are talking about the transistor as an amplifier, I will discuss these two, and these two combinations are pertaining to the digital electronics. Okay, so when I am providing this as a forward bias, this as a forward bias, this as a reverse bias, then transistor is representing a state of the digital electronics basically. So let me clear this again further. So this is the on stage or this is the off stage when we are talking about the digital electronics. So if we are providing this forward and this reverse, then these two combinations are representing the digital states. So on means one in the digital, we know that there are 0 1 on. So this is like that. So this you will study in the digital electronics. I have already mentioned this. So we are interested in this state. This is in, and for our all, as I already told you, for the general purposes, for the general purpose use of the transistor is as an amplifier. So in this configuration, when we are providing forward bias to the junction J1 and reverse bias to the junction J2, then what we are essentially doing, we are using a transistor as an amplifier. I will discuss the nomenclature. What is the nomenclature here? So this is as an amplifier here, and this is the there are particular modes. So transistor saturation, cutoff, and active mode. So I will discuss them later. So okay, right now all you need to understand. So if for our purposes, we will put this junction as a forward bias and junction J2 as a reverse bias. And we know that how to provide forward biasing to a PN junction and how to provide reverse biasing a PN junction. We are familiar with this, okay? Because we have already studied those things in the unit 1. Now we will discuss the current flowing mechanism. So what happens when we provide forward biasing to this junction and reverse biasing to this junction? Okay, we only use actually the possibility is there. This could be reverse bias, but this is useless. Okay, we don't use it. Okay, so let me clean this. Okay, now we will discuss the current flowing mechanism. So we know that this is the PN junction, and what happens when we provide the forward biasing to a PN junction? So let me give you a recap of the PN junction in forward biasing, which we have already studied in the unit 1. So what happens? So basically, this is the PN junction. And we are providing a forward bias. And we know that what is happening here. So initially there was a depletion layer, all the things that we have studied in the PN junction. The depletion region, the diffusion process. The diffusion process is because of concentration gradients. So all we need to remember all those things, the depletion layer, the diffusion process, and diffusion is because of concentration gradient, and then there is a electric field rises, and because of electric field there is a drift current, and because of drift current there is equilibrium position. So when this drift current and the diffusion current is equal, then there is equilibrium position, and when we applied the external electric field with the help of some battery, then that electric field opposes that electric field opposes this electric field. So this is the applied electric field, and this is the electric field inside the inside the PN junction. And this we have already discussed. And what we need to understand here, that here the majority of electrons, sorry, holes, and here electrons. So what happens when this potential barrier or this built-in potential is broken? What happens when this built-in potential, when this applied electric field overcomes this built-in potential? The diffusion process starts again, and the electrons will move this side. Electrons will move this side, and the holes will move this side. And what will happen? These electrons are moving this side. These electrons are moving this side at the p type, at the p type, at the p region. These electrons are moving. So if these electrons are moving at the p region, then in between, there are a large number of holes are here. There are a large number of this. We are understanding PN junction in the forward bias. So we are recalling the concept of the PN junction, which we will use here. So and it will make our explanation very easy. So this is when these electrons are moving. So in between they will recombine with the holes, because whenever these electrons are moving, then definitely if there is a very good probability of recombination. If these electrons are recombining, then what will happen? These holes will diminish. So electron hole pair will diminish. Because of recombination, EH pair will diminish. And here, p-type material is electrically neutral. So this p-type material, and we know that this n-type material is also electrically neutral. So in order to maintain the electrical neutrality, so who will maintain the electrical neutrality here? This battery will maintain. What will happen? So there will be some new holes created. In order to maintain the electrical neutrality, the new holes will be created. Like this. So here new holes will be created, and these electrons are pulled by this battery. Here you can understand, this is the positive terminal. And we know that the positive terminal attracts the electrons, and it will attract the electrons from the bonds, and it will create new holes in order to compensate the holes which are destroyed by the recombination process. This you need to understand. This is the basics of the PN junction. Then we have already discussed in the PN junction the process of recombination. And these electrons are moving. Now the current is flowing. We know that. So these electrons are moving here. These electrons are moving here. And if these electrons are moving here, then definitely we know that this is the direction of current. And this and at this side, how you can understand? If these holes are moving here, then again there is a recombination is taking place. But we know that n-type material is electrically neutral. This n-type material is electrically neutral. Then what will happen? We need more electrons in order to compensate the electrons which are diminished in the recombination process. So, and again we know that the electrons are already coming by this wire. So here the electrons will, more electrons will, and this will continue. This will continue because the battery is here. अगर बैटरी का कनेक्शन काट देंगे तो ये सब नहीं होगा, तो फिर वही इक्विलिब्रियम वाली बात आ जाएगी. So this is how the current flows inside a PN junction. So this we have already discussed. So now again I have given you a revision of the PN junction, and I will use this concept. And if you have understood this thing clearly, I have already told you in the class of PN junction that you can understand any kind of transistor or any semiconductor device if you have command over the PN junction. If you know what is really happening inside the PN junction. Okay, so This is what happening inside the p-n junction. So again I am telling you, these electrons are recombining, and in order to compensate, new holes are generating. How the new holes are generating? The electrons are coming out, because electron can come out, hole cannot come out. Okay, we know that hole is only inside the material. So these electrons, and again these electrons are moving here, and in order to compensate the recombination process. So this is happening, and continuously battery is providing this field, and we know that battery is continuously applied here. We have not switched off the battery. As we are not connecting battery, the p-n junction will be, there will be no current, we know that. And if we are connecting the battery, then definitely there will be some current. So this was the current flowing mechanism inside the p-n junction when it was forward bias. So again, here, now we will use this mechanism for the transistor. Okay, so now we shall study the current flowing mechanism inside the transistor. Well, now again you can